In this example, we will use the sensitivity analysis tool in StarDrop's MPO Explorer module to check if the ranking of compounds in a dataset is sensitive to any of the criteria or importance values in a scoring profile. This is important to consider because if the compounds we would choose are very sensitive to a property criterion, we should carefully consider if this criterion is appropriate to avoid missing potentially valuable opportunities. This analysis can also help us determine if different values for a criterion would have an impact on the strategy for a project. For example, if there is a disagreement regarding the most appropriate criterion to use. If the ranking of compounds is essentially unchanged within a reasonable range of values, this means that the scoring profile can be used with confidence that the ultimate selection will be robust to the chosen criteria. From the File Open menu, open the file 5HT1A library. The dataset contains 285 compounds for which the potency, pKi, against the intended target, 5HT1A, has been experimentally measured, and a number of other absorption, distribution, metabolism and excretion properties have been predicted. Scores against the required profile of these properties have been calculated for each compound using probabilistic scoring. To see the scoring profile that has been used, select the Scoring tab in StarDrop and click on the header of the column entitled 5HT1A Project Profile. We will use the sensitivity analysis tool in MPO Explorer to check how sensitive the ranking of the top scoring compounds is to the criteria and importance values defined in this scoring profile. Click on the Sensitivity button at the bottom of the Scoring tab, and this will perform a sensitivity analysis and display the results as shown here. The table at the top shows the sensitivity of the ranking of the top scoring compounds to changes in the value and importance of each property criterion on a scale of 0 to 1. A high value indicates that the top ranking compounds will change significantly for only a small change in the criterion value or importance. In this example, we can see that the value sensitivity of the criterion for 5HT1A affinity pKi is 1, the maximum possible sensitivity. Selecting the value sensitivity enables you to see the impact of a shift in the value for this criterion on the ranking of the compounds in this dataset in the plot on the bottom left. In this plot, a property shift value of 0 corresponds to the value of the criterion in the current profile and hence has a sensitivity of 0, i.e. the rank order is unchanged because the profile is unchanged. However, we can see that only a small increase in the value of the criterion results in a high sensitivity, i.e. the rank order will be changed significantly. Therefore, we need to explore the effect of this change on the top ranked compounds. Click on the point corresponding to a property shift value of approximately 0.7, corresponding to a criterion of 5HT1A affinity pKi of greater than 7.7. The original criteria was greater than 7. This shows a plot in the bottom right, showing the original scores on the x-axis and the scores corresponding to the profile with the new criterion on the y-axis. This is coloured to show the most significant changes in rank. Points coloured red indicate compounds with a significantly decreased rank, whereas points coloured yellow indicate compounds with a significantly increased rank. From this plot, we can see that a number of the highest ranked compounds, according to the original score, are ranked significantly lower by the new modified scoring profile. This might change our choice of compounds from this dataset, so we would like to check which compounds this affects. Click on the rightmost red point in the plot to highlight the corresponding compound in the dataset. From this, we can see that this compound is the highest scoring based on the original profile. However, the measured pKi of this compound is 7.54, so we can understand that a small increase in the criterion from 7 to 7.7 would significantly change our view of this compound. It may be worth considering this compound, and possibly other similar compounds highlighted by the plot, in more detail before committing resources to further study. Now select the importance sensitivity for BBB log-brain blood in the table. The plot in the bottom left shows that even a large change in the importance of this property criterion will only have a small effect on the ranking of compounds. Note that the maximum sensitivity in this case is only 0.06 for an importance of 1. You can confirm this by selecting the point corresponding to the importance of 1 as shown here. The resulting plot in the bottom right shows that there is no significant change in the ranking of the top compounds. From this, we can conclude that the selection of compounds will not change significantly if we vary the importance of BBB log-brain blood within a reasonable range. We can use this importance value with confidence that it is not inappropriately biasing our decision. For more examples of some of StarDrop's other features, take a look at the tutorial section in the Optibrium community.